little overview of the flooding from October 2018 of the Trinity River. Thanks to our new Patreon supporters, Daniel Park, Brian Lejic, Gary Elswick, and Alexander Williams. Welcome to the family, and glad to have you here. It's a pretty quiet day, and we're kind of catching up on things, so I figured I would give the drone a rest. Well, we're heading into another weekend here. Wish we had cause to celebrate, but I don't know, it is Friday, and we've got some weather to look at. Let's look across the southwestern U.S. right now. Well, we've got that Pacific front, which has come out into New Mexico there. And yesterday, remember we saw that system looking something like that right there. It is pushed eastward. And back behind it, you can see the cooler air. So we can see that back behind the dry line in West Texas, we've got lots of 80s and some 70s, but definitely very dry air. And it's only once you get west of the cold front, we see the temperature start to drop from the low 70s into the 50s. So that's very cold air. Let's put on potential temperature and kind of remove the effects of elevation. Let's give that a shot. So this shows us the very well-defined thermal axis from Midland all the way up to, say, Shamrock. Now, one thing that I do notice is maybe that front is a little further to the west. See that thermal gradient in this area here? Well, I've kind of got the front drawn out a little bit ahead of it, so I might be inclined to maybe bring it back this way. Let's see if that fits. Okay, let's try that. Does that fit? Yeah, I kind of like that. See, we go from 72 there at, I guess that's Roswell, down to 68 and 65 as we go west. And then we try comparing that in the dry sector. Yeah, I'd say that's probably a very similar air mass. And the isotopes are about the same between Midland and Roswell, indicating that if we correct the temperature for elevation, they're going to be about the same. So this is all probably part of the very same air mass. So I think for now I'm going to go with this. So one thing that we can do to see what we think about that is to maybe look at the station where we've had frontal passage. Let's try Klein's Corner. The identifier for that is CQC. So there's all the METAR reports going back about 12 hours. Well, let's see. We've got very cold conditions. It is a very high elevation station. We go from 39 overnight, and temperature rises rapidly, and it peaks at about 55 Fahrenheit. Let's try pressure. Tune in at 80, 79, 80. So it's pretty steady. 74 drops off quite a bit during that last portion. Normally behind the cold front we expect to see a sudden rise in the pressure. So this tells me maybe the front is even a little bit further to the west. But man, look at that wind. Gusting up to 45 knots out of the west-southwest. So I'm just not really seeing a frontal passage there at Klein's Corner. Let me try Albuquerque. It's going to be a little bit further to the west. Yeah, right there. That's Albuquerque. Let's see what they've got going on. I'm going to start just looking at pressure rises. 2978 falls off, 2074 down to 2066. Okay, that's pretty low. However, the winds are strongly out of the west during that very last observation. Okay, let's try truth or consequences. No, actually, let's go a little bit further west. Let's go to Grants. So what I'm doing here is I'm going through and trying to find where the pressure rises begin. It's actually very cold there at Grants. It's in the 40s. I think we're back in the cold air there. Now I'll show you another resource you can use. Go to the SPC Mesoanalysis website, And we're going to look for the pressure falls, pressure change. So this is showing kind of a very large area of pressure falls out over eastern New Mexico. And we're not really seeing the pressure rises until you get way back here in Arizona. So it looks to me like there's some very strong upper level lift working on this area right there. So we're going to expect to see showers in that area. Yep, and there they are. Looks quite unstable. In fact, you can even see some diffluence in the upper level wind flow there. Pretty spectacular there. And a lot of the deeper towering cumulus in this area right here. So I think we've probably got a bit of a shortwave disturbance working through the Four Corners area, or at the very least maybe a left front quad of a Jetmax. The divergent left front quadrant of a Jetmax, that is kind of a combination there of the effects of curvature and the exit region of a jet. You get some effects there, kind of an imbalance in the wind flow that favors upward vertical motion and clouds, bad weather, kind of what you see here. And then let's see, further out to the west, there's a big baroclinic shield there, a lot of cirrus across much of Texas. So the jet stream is probably going to be back in, kind of like in this area here. Maybe taking more of a slope, kind of like that. Okay, so we're starting to get a picture of what's on the upper level chart. And as far as that cold front, man, that's a tough one. I would probably, I'd say we could probably bring it back like that a little bit, possibly. But I think, the cold front has gone through Deming. Any sign of cold front passage not reflected in the pressure field? Is it reflected in the temperature field? Not really. Dew point? Nope, just some drying. It is sort of reflected in the wind field, though. You can see a wind shift there, about 16Z. Swings around from south to west and becomes very gusty. Now, that could be the boundary layer coupling with the upper level flow, so that's not really definitive there. Because, 15Z, we start getting the warming, see the temperatures coming up. So we're going to go to Weather Nerds and try to get some help. I'm going to draw a line from about Yuma, across Phoenix and Roswell, out towards Lubbock and Dallas. So let's do that. Well, here we can absolutely see the front. There it is right there. Looks like it's around the Continental Divide, kind of in that area right there. See how there's very little change in the isotropes until you get right there. It would be nice to have an indicator where exactly that is, but looks like that's about just to the left of halfway along that line. So that's going to put it right around the Rio Grande Valley. Okay, so this is giving me some information here, and what's interesting is you can kind of see the gravity waves out ahead of it. See how the flow gets very amplified downstream of that front. So this is all definitely part of the warm air mass. And there's the jet, kind of staying close to that frontal surface there. Okay, so this is interesting. Let me adjust this a little bit more. So I think this is the final analysis. This is what I've got. This looks the most meteorologically consistent. Looks to me like there's a low just northwest of Albuquerque and a cold front coming up on the Rio Grande Valley. And that lines up perfectly with what we got on the high-resolution rapid refresh. So cold front extending down to Deming, just now passing through there, and looks to me like a warm front up there near Santa Fe and Tucumcari. And that does put the pressure rises back in that area along the New Mexico-Arizona border. Looks like a little bit of air from the northern Pacific, maybe British Columbia, heading south through Nevada. There's that northerly flow back behind it. And then, of course, out in the Great Plains, there's that stationary front. It's been out there for a couple days now. Cool air up there in Kansas. And then we've got the dry line. This is not a trough. This is a dry line extending from about Enid down to Wichita Falls, Abilene, and looks like Ozona. Now there is a satellite product called the Air Mass. This Air Mass product is a multispectral product, and it's useful for finding contrasts that you normally wouldn't otherwise see. The actual colors really don't mean anything too much. It's the gradients that we are looking for. Like you can see between this upper level moisture, it's got a kind of a purple shade, and the red. And this is part of the drier air mass out to the west. Of course, some parts of it are kind of humid, especially in the mid-levels, but overall, the upper troposphere is kind of dry in this red area. So I don't really see the front, but it looks like there might be kind of a vague transition in this area here. And I think that probably, maybe even here, yeah, see maybe something in there. I don't know. I think we're kind of splitting hairs, but at least you kind of get the general idea. I think we've pretty much done all we can to really squeeze out where that boundary is. Well, using that multispectral imagery, we do see the huge plume of subtropical moisture coming all the way up into the southern plains. So even though we do have that dry line in place and the triple point approaching upper level lift, we're having trouble with surface heating. So a lot of this high cloud is keeping things shut down. And with a very stout cap in place, we've got very little chance of getting any good thunderstorms going. And just a quick look out there in California, where we do have a few viewers. Not much going on. The main dominant feature is this high pressure offshore, giving us a little bit of a northwesterly component flowing down the valleys. Southern California, of course, picking up the usual westerly flow, and temperatures just about in the 50s everywhere that you look. I do like that multispectral imagery, very cool, and we can see the homogeneous nature of the tropical air over the Gulf and over Florida. Do we see an air mass discontinuity? Yeah, I see something right there. Of course, that could be an upper level discontinuity. Maybe the better moisture aloft is out in this area. But, we'll take a look at it on the surface chart. There's the weather pattern in the southeastern U.S., and yeah, that little discontinuity we saw on the satellite, that's going to be upper level. Not seeing much going on there at the surface. High pressure over Florida, that's kind of like a little bit of a Bermuda high push there into Florida and then out to the west. Southerly flow coming up off the Gulf, and lots of mid-60s dew points. That front that's been hanging around from the Carolinas out to Oklahoma, that's lifted north. And so we got a pretty well-developed Bear Clinic low in Missouri, and that boundary extends eastward across Kentucky and Virginia. We got a very, 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 very stagnant weather pattern in the northeast U.S., that very persistent high-pressure area up there in Quebec and Ontario, still hanging on and still bringing that northerly flow. That's been the story over the entire past week. And so that's helped reinforce that boundary to the south, which is approaching the area from the south, and we're getting a few areas of IFR, marginal VFR, and showers, all the way from Illinois to Pittsburgh, even Washington, D.C. there. And then the flow becomes a little more cyclonic out around Iowa and Missouri. There it is up to the north, all those frozen lakes up there in Ontario and Quebec. Very nice weather across New York, and down to the south, the frontal boundary. And we can see some evidence of the strong upper level flow by those very well-defined herringbone patterns, that transverse bands, some mountain wave activity there in Kentucky and West Virginia. So we got cirrus spreading in, and then underneath that, some altostratus layers developing, anywhere from Cleveland to Chicago southward, and then we get into the thicker clouds and the rain down around Indianapolis and Dayton. And very little going on in the northwestern U.S. The main influence is this lee side trough in Alberta, all the way down to Great Falls. This is typically what we get with a strong zonal flow. Got the westerly jet stream winds going across the northern Rockies, and we get that conservation of angular momentum, which helps to carve out that lee side trough there. And the other dominant effect is high pressure offshore, kind of a big elongated ridge coming into the northwestern U.S. and giving us kind of a predominant westerly component to the surface winds. So overall, pretty quiet around the country and very similar to what we had yesterday. Okay, so I know a lot of you are probably wanting to get some experience with soundings, and we can certainly bring up a few examples. Let's look at our thermal boundary. This is the NAM for this afternoon, and that's what we're looking at there on the surface chart. Pretty well defined. And then we can see that other cold front there in Albuquerque southward. So that matches up pretty well with what we have there. So what would our soundings look like? Well, we know that north of a warm front, we expect to see kind of a shallow inversion, a few thousand feet off the surface, and then above that, we expect to see very humid air with higher dew points and some evidence of clouds and precip. So let's drop a forecast sounding over Chicago. That's going to be a little bit north of that cloud zone, kind of on the edge of that altostratus. So let's see what it shows. There's Chicago, very humid air mass, and the top of the frontal layer probably about there. So it's about 5,000 feet deep. And then we look over on the wind scale, and we can see that below that frontal inversion, the winds are out of the southeast to even the east. But above that, they're out of the west. And we pick up those jet stream winds. There's 100 knots at 300 millibars, and it looks like our peak wind is 135 knots at 210 millibars. That's going to be up at about 37,000 feet. So if you're flying from New York to San Francisco, you're probably going to have to tack an extra hour onto that flight due to the headwinds. And due to those very strong headwinds, we can see that on the photograph. See here at the top left. Now, I know some of you may not be familiar with photographs, but this is just a plot of wind direction and wind speed with height. So we start out at the surface. See that 0 right there? That indicates that our surface winds are in that spot right there. Now you notice it's on the bottom left corner of this graph. And whenever our dot is in that spot, that means we have northeasterly winds. So in other words, the trick with photographs is we have to consider the winds as vectors, not as barbs. In other words, barbs tell us where the wind is coming from. With vectors, that tells us where the winds are going to. So if we have northeasterly winds, well, they're coming out of the northeast. If you're facing into the wind, you're looking to the northeast. But the winds are actually heading towards the southwest. Kind of like right behind you. They're heading in that direction. So we plot the winds where they're heading to, which is in the southwest part of the graph. Okay, so that means at the surface, the winds are blowing like that. Okay, got it? So those are winds blowing to the southwest from the northeast. It's kind of hard to see that wind barb. Anyway, as you go up to higher levels, at 1 kilometer, it comes into this part of the graph. 1 kilometer height is about 3,000 feet. And any wind that's up in this level, that's in this corner of the graph, is coming out of the southeast, blowing to the northwest. Yeah, certainly we see that down here. And then in the rest of the graph, anywhere above 2 kilometers, anywhere above 5 to 6,000 feet, this corner of the graph is winds blowing from the southwest to the northeast. Yeah, that certainly checks out. They're a little bit more westerly, but still applies. And then they kind of stretch out, indicating our winds are getting stronger and stronger with height. So by the time you're up at 6 kilometers, you got winds at about 80 to 90 knots. And they just keep getting stronger. So how do you get the winds at any particular level? Let's try 1 kilometer. Well, to get the winds, all you have to do is draw a line from the origin of the graph, which is the center of these circles. It's always going to be at that center of that cross. You draw a line from there to the desired level. And you can see we get this line here that goes like that, which is indicating our vector is about 20 knots long, and it's pointing in that direction. What's our winds at 6 kilometers? Well, there's our 6 kilometer point. So we draw a line from the center of the graph, the origin, all the way out to 6. It's not a very good line there, but it's showing that the winds are blowing like that. And the length of that line is quite long. It's 90 knots. So if I took that line and kind of measured it against this grid, it's about 90 knots long. And so if you want to look at all the winds, you're going to get something like this. If you look at winds at all the levels, you can just plot it out like that. So you can just pick what level you want to look at, and that gives you your winds. Okay, so that's a quick primer to photographs, and we do see some very good storm relative helicity, assuming we could get storms going. See that little hook? That's always a good thing to have when you're expecting tornadoes. Now, there's certainly not the instability. This is a very stable profile, so we're not going to get tornadoes out of this kind of situation. But if we did have a rogue storm that was feeding off of instability, and say it was moving to the east at 25 knots, we would sweep out this good 0 through 1 kilometer helicity. That's probably about 300 or 400 as far as units for SRH. So it's hard to believe. Chicago, 46 degrees, but they've got a great tornado sounding. They just don't have the instability. Okay, so that brings us to our forecast for tonight. And yeah, there's that baroclinic zone right there from New Mexico all the way up to Nebraska. Cold core low starting to cross the Rockies, and then our tropical airs out here to the east. So a cold front. Looks like a couple little waves along that polar front extending out into Kentucky. And then our cold front is now starting to come out into eastern New Mexico this evening and start to approach West Texas. And we don't have a whole lot of moisture out there in West Texas, so I guess we're going to just get elevated storms. But let's see how close the moisture is. Well, dry line is all the way up near, as we said, Ozona, Abilene, Wichita Falls, and Enid. So as the front approaches, it's going to have to get all the way out there into North Texas and the Concho River Valley before we can actually get any surface stuff going. So let's see what happens. Overnight, yeah, looks kind of dry. That's midnight. Looks like the cold front is past Amarillo. It's passing Lubbock and Midland. And then by morning, front is already spilling out towards Oklahoma City, Fort Worth, and then down to maybe Fredericksburg and Del Rio. Now we're starting to get some surface-based convection there. Although it's still morning, this is probably still a little bit elevated, but some cells starting to get going there near Dallas-Fort Worth. And you can see a lot of the cold air starting to come south on the backside. So we're going to have a bit of a cold front dropping south like that. So there's how it looks in the morning. And then let's see, as the day goes on, midday, it's going to look like that. Things push rapidly eastward. And then by evening, looks like a very well-developed cold front from St. Louis area down to Little Rock and Austin. Looks like it's going to be fairly dry probably starting to get a little bit of, probably the capping has taken a toll there. And not much going on in the Midwest either. However, a series of cold core lows out to the west, keeping things kind of unstable from the Rockies all the way up to California. And up to the north looks like another cold front trying to push south out of Alberta and Saskatchewan. This time of year, it's probably not going to make it too far. And then it looks like some snow there for Minneapolis and Duluth. Squall line finally gets going overnight around Louisville, Memphis, and Indianapolis. And then by morning, that squall line is pushing through Nashville and Huntsville and Cincinnati. By Sunday evening, that frontal system has moved well east into the Pacific. Yeah, that's not the Pacific. Into the northeast U.S. And then there's our front, Virginia to Georgia. And then it looks like everything that north of there is kind of an occlusion like that. Looks like some wintry weather there in the Montreal area, parts of Ontario, and then looks like more unstable. The air there for the west coast. Lots of snow showers and rain showers in the high deserts of Nevada and parts of the San Joaquin Valley. And then giving us one more frame towards the very end for Monday night. Some baroclinicity coming together there in North Texas, another frontal system in West Texas. And that's our weather picture. Looks like a new front coming south out of Canada. And a pretty well-defined upper level low there in the Seattle, Vancouver area. Looks definitely kind of stormy on that in that region. And let's take a quick look at the soundings along this warm front, because this time of year we're kind of concerned about severe weather potential. I'll kind of drop that right along the warm front around the Fort Worth area for Monday. Kind of a lackluster lapse rate there and even some capping. And not seeing much in the way of warm temperatures, 62 over 61. Let's drop that further south of the front, 67. Yeah, it's not very warm. We've had very little return moisture, I guess, for Monday. The air mass is still pretty well worked over. Okay, guys, that's about all I got for today. Thanks for watching. Tomorrow is going to be a supporters-only stream. I don't think we've ever really done that. Even a few years ago, I don't think we've ever done such a stream. So you're welcome to send in your Patreon donation if you want to get in on that over the weekend. And for those supporters who are going to be watching it over the weekend, keep an eye on your email, because I'm going to try to push it out that way. And if not, log into Patreon, and I'll probably have the link posted there for our supporters. Otherwise, we'll see you probably around Tuesday. So have a good evening and take care, and we'll see you soon. Bye-bye.